Look up tonight. Count the stars you can see. Maybe 2,000, 3,000 if your eyes are sharp and the sky is clear. Now notice what dominates. Not the stars. The darkness between them. That darkness fills most of what you see, and everyone tells you the same thing. Space is empty. Space is black. That's just how it is. But that's not an answer. That's just repeating words. When you actually understand why the night sky stays dark, something shifts. The question seems innocent. The answer will show you that darkness itself is evidence. Evidence of something Einstein saw in his equations before anyone saw it in the sky. By the end, you'll look up and see time itself written in that darkness. So let me ask you plainly, why is the night sky dark? Your instinct says, because space is mostly empty. Stars are far apart. Light fades with distance. Reasonable, sensible, completely beside the point. Let's imagine something simple first. You're in a room, one candle, dim, add another candle, brighter, add 10, brighter still. More light sources, more light. This isn't physics. This is counting. Now let's take this same logic and apply it to the universe. Assume, as many did for centuries, that the universe is infinite. Stars scattered throughout, going on forever in every direction. And assume the universe is eternal. Stars have always been there, always burning. If this is true, then when you look up at the sky, your line of sight in any direction eventually must hit a star. Not maybe. Must. Because if space goes on forever and stars fill it, there is no line of sight that escapes into emptiness forever. Geometry doesn't allow it. So every point in the sky should glow, not with the faint twinkle of distant stars, no. With the brightness of a star's surface. The entire sky should be as bright as the sun, uniformly in every direction. You should not see darkness. You should be blinded. But you're not. You see darkness. Overwhelming darkness. A few scattered points of light, sure, but the vast majority of the sky is black. This is the paradox Heinrich Olbers described in 1823, though Kepler had noticed the strangeness centuries earlier. Olbers calculated the expected brightness of the night sky if the universe were infinite and eternal. The result wasn't slightly off. It was catastrophically wrong. The night sky should be roughly 50,000 times brighter than what we actually see. 50,000! That's not a rounding error. That's reality telling you that one of your assumptions is broken. For decades, no one had a satisfying answer. Some said dust. Maybe dust clouds between stars absorb the light, darken the sky. Clever. Wrong. Because dust doesn't simply swallow light and vanish it. Dust heats up. Hot dust glows after enough time. And we're assuming an eternal universe, so time is infinite. The dust would heat to the same temperature as the stars themselves and glow just as bright. The darkness returns. Others said, maybe the universe is not infinite. Maybe there's a finite number of stars, and beyond them, nothing. But this is arbitrary. Why would the universe simply stop? And even if it did, you still have the problem of every visible star contributing light. The darkness remains too dark. Strange. The darkness between stars is not absence of light. It is a clue, and the clue points to something no one in Olbers' time was ready to consider, that the universe itself might have a history, that it might not have always been here, that time, like space, might have edges we are looking at when we look into that darkness. But to see this, we must first ask a simpler question. Not why is the sky dark in general, but why is the sky dark right now, in this moment, when you look up? What exactly is missing? The missing light. That's what we're looking for. If the universe were infinite and eternal, light should be arriving from every direction, from every star, from every distance. But it's not. So either the light was never sent, or it was sent but has not arrived, or it has arrived, but we cannot see it. Let's test each possibility. First, what if the universe is not eternal? What if it had a beginning? Think of it this way. You're standing in a field at dawn, and someone far away begins shouting, but sound takes time to reach you. If they started shouting only a moment ago and they're far enough away, you haven't heard them yet. Not because the sound is weak, not because something blocked it, because it's still traveling. It hasn't had time to arrive. Now replace sound with light. Replace the person with a star. If the universe had a beginning, if stars have only been shining for a finite amount of time, then light from the most distant stars simply hasn't reached us yet. There hasn't been enough time. In 1929, Edwin Hubble looked through a telescope at distant galaxies and measured something unexpected. They were moving, not drifting slowly, receding, and the farther away a galaxy was, the faster it was moving away from us. This wasn't galaxies flying through space like ships on an ocean. This was space itself expanding, carrying galaxies with it. And if space is expanding now, that means it was smaller in the past. Trace it backward and you reach a moment roughly 13.8 billion years ago, when everything we can see was compressed into an unimaginably small region. A beginning. The universe is not eternal. It is 13.8 billion years old. Light travels fast, about 300,000 kilometers per second, but it doesn't travel infinitely fast. So light from a star 20 billion light years away hasn't reached us yet. There hasn't been enough time for that light to make the journey. The universe is younger than the distance is wide, or rather the observable universe has a horizon. Beyond a certain distance, we cannot see anything, not because nothing is there, but because light from those regions hasn't had time to reach us since the beginning. The darkness you see in part of the sky is not empty space. It's space whose light is still on its way. That darkness is time made visible. Do you feel what just happened? The sky is dark partly because the universe is young, but this only explains part of the darkness. Because here's what's strange, even the light that has reached us, light from stars and galaxies well within the 13.8 billion year horizon, even that light is not as bright as it should be. The sky should still be far brighter than it is, even accounting for the finite age. Something else is stealing brightness, and that something is the expansion itself. Imagine you're pulling on both ends of a spring. As you stretch it, the coils spread apart. The spring doesn't disappear. It just gets thinner, more spread out, less dense. Now imagine space doing this, not to a spring, but to light itself. Light is a wave. It has a wavelength, a distance between peaks. When space expands, it stretches that wavelength. A wave that started out as visible light, blue or green or red, gets stretched into infrared, then into microwaves, then into radio waves. The light is still there. You just can't see it anymore. Your eyes aren't built to detect infrared or microwaves. So that light, from your perspective, has gone dark. This is redshift. Light from distant galaxies, galaxies billions of light years away, is stretched so severely that it shifts out of the visible spectrum entirely. The most distant galaxies we can detect are visible only with infrared telescopes. To the naked eye, they contribute nothing. Darkness. Not because they're faint, because their light has been pulled into a form we cannot see. Darkness is not empty. It's light we can't see yet, or light stretched beyond seeing. And here's the deeper piece. Expansion doesn't just stretch light. It dilutes it. Imagine you have a flashlight in a small room. Bright. Now imagine the walls of the room start pulling away from you in all directions, the room doubling in size every second. The same amount of light is now spread over 4 times the area, then 16 times, then 64. The light doesn't get dimmer because the flashlight weakens. It gets dimmer because space itself is growing, thinning out the light. This is happening to every star, every galaxy. The universe expands, and the energy density of light drops. Even the light that reaches us arrives weaker than it should be, because the space it traveled through grew while it was in transit. Your intuition rebels here. It should. Intuition was built for a static world, where space is a fixed stage and objects move across it. But space is not a stage. Space is dynamic. It expands. It has been expanding for nearly 14 billion years. And this expansion is why the sky is darker than Olbers predicted, even for stars whose light has had time to reach us. But this creates a problem Einstein saw coming. If the universe is expanding now, then it was denser in the past. And if you run the expansion backward, you reach a point where everything, all matter, all energy, all space itself, was concentrated in an unimaginably hot, dense state. What we call the Big Bang, not an explosion in space, an expansion of space. And this is where the darkness stops being a simple question about missing light and becomes a question about time itself. Because if the universe had a beginning, then when you look into the darkness, you're not just looking into empty space. You're looking back in time. Light takes time to travel. When you see the sun, you're seeing it as it was 8 minutes ago. Because light takes 8 minutes to cross the distance from the sun to your eyes. Look at a star 10 light years away. You see it as it was 10 years ago. A galaxy 1 billion light years away. You see it as it was 1 billion years ago. This is not metaphor. This is geometry. Distance in space is distance in time. The farther you look, the deeper into the past you see. Now push this to its limit. The most distant galaxies we can observe are roughly 13.4 billion light years away. We see them as they were 13.4 billion years ago, only 400 million years after the universe began. Look farther and you approach the edge, not of space, but of time itself. Beyond a certain distance, there were no stars yet, no galaxies, just hydrogen gas, cooling, not yet collapsed into anything that could shine. And beyond that, even farther back, the universe was so hot and dense that atoms themselves could not form. Electrons could not bind to nuclei. Light could not travel freely. It was trapped, scattering endlessly off free electrons, like trying to see through fog. This lasted for roughly 380,000 years. Then the universe cooled enough for atoms to form. Electrons settled into orbits around nuclei. Light, for the first time, could move without scattering. It has been traveling ever since, stretched by expansion into microwaves, filling the sky uniformly in every direction. We call it the cosmic microwave background. It's the oldest light in the universe, a photograph of the moment the universe became transparent. But to your eyes, it's invisible, dark. The darkness you see is the edge of time made visible, not emptiness, not absence, a horizon. When you look at the night sky, at the darkness between stars, you are looking toward the beginning, toward the moment before galaxies, before stars, before light could travel. The darkness is not nothing. It is the boundary of the observable universe. It is as far back as light allows you to see. You cannot see farther, not because there's nothing beyond, but because there is no light from beyond that has reached you yet. The darkness is time's limit, written across the sky. Let that settle. Every direction you look into darkness, you're looking backward in time. The patch of black sky above your head right now is not empty space waiting to be filled. It is the past. Specifically, it's the part of the past so distant that its light has either not reached you, or has been stretched into invisibility, or corresponds to a time before stars existed. When you stare into that darkness, you're staring at the edge of history. Think of it like standing in the middle of a vast, dark field at night, holding a lantern. The light reaches only so far, beyond that distance, darkness. Not because the field ends there, because your light has not reached farther. Now imagine the field itself is expanding, pulling away from you in all directions. The edge of your light, the boundary between what you can see and what remains dark, is not moving outward as fast as the field is expanding. In some directions, the expansion is faster than light can chase it. Those regions are beyond your horizon, forever dark, not because they're empty, but because the light from there will never reach you. The universe is doing this. And the darkness you see is that horizon. This is where Olbers' paradox dissolves completely. The sky is dark because the universe is young, because it is expanding, and because when you look far enough, You're looking back to a time before there was anything to see. The infinite, eternal universe Olbers imagined does not exist. The real universe is finite in age, dynamic in structure, and bounded by horizons we cannot cross. Darkness is not a failure of light. It is a consequence of time. Einstein predicted this. Not the Big Bang, not initially, but the expansion. His equations of general relativity, published in 1915, described a universe that could not stay still. It had to either expand or contract. Einstein himself didn't believe this at first. He wanted a static universe, stable and eternal, so he added a term to his equations, a cosmological constant, to hold everything in place. He called it his greatest blunder, because 13 years later, Hubble observed the expansion directly. The universe was doing exactly what Einstein's original equations said it must. It was growing, and in growing, it was creating the darkness we see. And this brings us back to where we started. But now you'll see it differently. Olbers looked at the night sky and asked, "Why is it dark?" He assumed the universe was infinite and eternal, and that assumption made the darkness impossible. Now we have the answer, not from one cause, but from three that weave together. First, the universe has a finite age, 13.8 billion years. Light from stars farther than 13.8 billion light years away has not had time to reach us. The darkness in those directions is not absence, it is waiting. Light is still in transit, crossing the space between there and here, and it will not arrive in your lifetime, or in the lifetime of the sun, or perhaps ever, because of the second reason. Second, the universe is expanding. Space grows between us and distant galaxies. Light traveling toward us gets stretched, pulled into wavelengths our eyes cannot detect. Infrared, microwave, radio. The light exists. You simply can't see it. And the expansion doesn't just stretch light. It dilutes it, spreads it thinner across a growing volume of space. Even the light that reaches us arrives weaker than it should. So the darkness is partly light transformed into invisibility by the expansion of space itself. Third, when you look far enough, you're looking back to a time before stars, before galaxies, before anything that could shine. The universe began hot, dense, opaque. It took 380,000 years for it to cool enough for light to travel freely. Beyond that boundary, there is no light to see. The darkness there is not just distance. It is history. It is the edge of the observable universe. The farthest back light allows you to look. Put these together, and the paradox vanishes. The sky is dark because the universe is young, because it is expanding, and because there is a horizon in time beyond which nothing is visible. Darkness is not nothing. It is everything the universe has not shown us yet. Remember Olbers' calculation? The night sky should be 50,000 times brighter. He was right about the math. He was wrong about the universe. The universe he imagined, infinite and unchanging, does not exist. The real universe has a beginning, a history, a horizon, and the darkness is the signature of all three. Now look at that darkness again. Same stars, same black sky, but you're not seeing emptiness anymore. You're seeing the limit of time. You're seeing the shape of expansion, stretching light beyond visibility. You're seeing light that has not yet arrived from the farthest stars, still traveling through space that is itself growing. Every patch of darkness is evidence. Evidence that the universe began. Evidence that it is still expanding. Evidence that we are looking at a boundary we cannot cross, not in space, but in time. The darkness that confused scientists for 2 centuries is now one of the clearest messages the universe sends. It tells us the universe is not eternal. It tells us space is dynamic, not static. It tells us that looking out is looking back. And if we look far enough, we see the moment when there was nothing to see, nothing but heat and light trapped in itself, waiting to cool, waiting to become transparent, waiting to become the stars and galaxies and darkness we see tonight. Einstein resisted this at first. His equations told him the universe must be expanding or contracting, and he didn't believe it. He forced his equation to describe a static universe because that's what intuition demanded. Then Hubble showed him the galaxies, receding, the farther ones faster, exactly as the equations predicted. Einstein let go of his intuition. He followed the evidence. And the evidence said the universe is not a fixed stage. It is a growing structure, and we are inside it, looking outward toward edges we can measure, but not reach. We can measure the expansion with extraordinary precision. We can trace the universe back to its beginning with confidence. We can see the light from that beginning, stretched into microwaves, filling the sky uniformly. What we cannot yet explain is why the universe began, why it expands, why the laws are structured this way and not another. I can show you that it happens. I cannot tell you why existence chose this shape. Not yet, but the darkness itself that we understand now. When you look up tonight, you're not staring into a void. You're looking at time's edge. You're seeing the observable universe's boundary written in black across the sky. The stars are moments in history, frozen at different distances, different eras. The darkness between them is not the absence of stars. It is the presence of limits. Limits of age, limits of speed, limits of visibility. Olbers thought darkness was a problem to be solved. He was right. But the solution was not to make the darkness go away. The solution was to understand what the darkness is. Not absence, not emptiness, evidence.